Screw threads are fundamental in engineering. They're one of the most commonly used forms of fastening components together using bolts and nuts, which screw together and can be used to fasten components together either with a nut and a bolt or by themselves. So we need to be able to produce screw threads on the components which we make. And on the lathe we have various methods of producing screw thread. One of the most basic methods is by using taps and dies, and in this video I'm going to demonstrate how to use taps and dies on the lathe to produce both external and internal screw threads. To produce an internal screw thread, a tool called a tap is used. The tap is made out of high-speed steel, same material that a drill is made out of. Very hard, very tough, and it has cutting edges called flutes. The teeth can be seen on the tap, which match the screw thread of the required bolt. In order to use a tap, the tap must be fitted into a tap wrench, which is a specialized holder which is used to hold the tap. In order to tap a hole, you must first have drilled the hole to the correct size. In a previous video, I drilled a hole 8.5mm diameter. That is the correct size to suit an M10 10mm metric tap. To set up the tap for producing the screw thread in the hole, firstly the tap should be inserted into the hole, and because the taps have a small hole in the end, that means that the tailstock centre can be advanced so that the point of the tailstock centre locates in the hole on the end of the tap, and that keeps the tap straight and true while it's cutting the screw thread. I'm going to take this out now because the tap needs to be lubricated so that the cutting action is smooth, so that it produces a clean and neat screw thread. This material here is tapping grease. That should be lightly coated onto the tap before using the tap. Place the tap into the hole and advance the tailstock until the point of the tailstock locates in the hole in the end of the tap. At that point, the chuck can be locked in a low gear, low speed, which means that the chuck is rigid and it won't turn. I need to put a little bit of pressure from the tailstock by turning the tailstock handle slightly. At the same time, I'll begin moving the tap wrench, and the tap will then begin to cut and screw into the hole. As the tap goes into the hole, it's moving forward, which means that I need to advance the tailstock hand wheel at the same time so that the point of the tailstock centre remains located in the hole in the end of the tap. This ensures that the tap goes into the hole straight and true. Once the tap has advanced into the hole about 4 turns, that means that the tap is set. There is no need after that to have the tailstock centre in the hole that can be removed and the tailstock moved out of the way. Following that, the remaining depth of the tapping can be done by using the usual method of half a turn forward, half a turn back, until the tap reaches the bottom of the hole. This can be seen by being unable to turn the tap any further. The tap can then be removed from the hole carefully. The swarf resulting from the tapping can be seen in the flutes, the grooves on the tap. The excess grease can then be wiped away and the hole checked for fit. As you can see, the bolt screws into the hole.